I'm a dinosaur watching the asteroid climate change get larger and larger. I'm hoping my next guest on Forum will help me sort out, am I hallucinating or should I move to higher ground? Join me when I talk with Dr. Kenneth Blumenfeld, Senior Climatologist with the Minnesota Department of Natural Resources. By the way, what is the difference between weather and climate? I'm Kel Heyl. I do design build, principally residential remodeling. My company lives and dies by the proposition, something is beautiful if and only if it's sustainable. This program is the first in a 3-episode arc inspired by the United Nations report by the Intergovernmental Panel on Climate Change, released in August. It was prepared by 234 scientists from 66 countries. UN Secretary General Guterres called the report a red code for humanity. The US Secretary of Treasury, Dr. Janet Yellen, calls climate change an existential threat. The city of St. Paul now has a chief resilience officer. Resilience is an interesting choice. It assumes climate change isn't an if, it assumes climate change is here, and the policy question is how to respond to mitigate the effects on the residents of St. Paul. The first third of the arc is about climate change in Minnesota. The second third is what St. Paul is doing about it. And the third third is what individuals are doing. My guest today is Dr. Kenneth Blumenfeld. His day job is Senior Climatologist at the Minnesota Department of Natural Resources. Welcome, Kenny.
Good to be here. Thank you for having me, Kel.
Thank you for coming. Did you have any experiences as a child that ignited a passion to understand climate and weather?
Oh my goodness, yes, that's a great question. I grew up in Minneapolis and I was already very interested in storms as a child. And I would go to the library and get books about, anything I could that was weather related. And I'd always go to the section about tornadoes. And then when I was 7 years old, a tornado went right across Lake Harriet about maybe 3/4 of a mile from where we lived, and a lot of kids in my classes saw the tornado or were even hit by it. And then that tornado tore across a lot of South Minneapolis, right through the Chicago Lake area and into Roseville. And that had, if I was already interested in the weather, that one cemented it for me. And then I was just, afraid of and watching storms in awe for ever since, really.
That storm, you're talking about the tornado, I was doing a building project then near the old Sears. Yeah. And the thing that I will never forget was the garage had a laminated tar roof, and a piece of it had been ripped off and it had been flung against the window, and it was like a saw had cut the frame of the window.
Right.
And the winds had picked up the top of a chimney and just sort of thrown it through the roof. So I remember that storm well.
Yeah, it was anybody who was around back then in the early 1980s would remember that because it was on a Sunday afternoon. It was a Father's Day weekend, and it was pretty well forecast, although the sirens went off a little bit late for most areas that were affected. And yeah, so where you were working is right by where some of the biggest, worst structural damage was.
Right. So, doctor.
Sure.
What did you write your dissertation on?
Yeah, so I studied extreme and hazardous weather. I actually went into graduate school to study the same things that had interested me as a kid, and what science helps you do, and what graduate school and my advisors helped me do, was structure it into a set of hypotheses or into a reasonable question. Um, and what's interesting was I had a theory about what happened to thunderstorms when they entered the Twin Cities that I think a kid told me when I was in 4th grade, that they all break up and the storms become a lot less severe. But I had to apply a scientific method to this. You don't get to just prove that you're right or wrong, right? You have to actually set up a way of testing this. And how do we know? And when I put it through the tests, it turns out that I was only barely right and I was mostly wrong. And it's that, some thunderstorms maybe do weaken when they approach the Twin Cities, but the really big ones, the ones that can produce tornadoes, the ones that can produce gigantic hailstones or maybe 80-mile-an-hour winds, those storms don't seem to be phased at all by entering a dense urban area. And so, yeah, I got to study something I'd always been interested in and turn it into a formal scientific question.
So you're a young person
Mhm.
and you're entranced with violent weather.
Right,
And then at some point you're a graduate student.
right.
Where along this trail did climate change become real to you?
Oh, that's such a good question. I'd always been, my father was a scientist. My father is a molecular biologist. He's retired now. And so even as I was forming sort of my junior hypotheses about the weather when I was a kid, I understood that you kind of have to trust what the scientists and the experts say too, because they've done research, which is something that most people don't necessarily understand. But they've come about their wisdom or their knowledge in a quite rigorous manner. And so I had read, even as a child, about the prospect of global warming, and there was really no sense that this was ever going to go away. I mean, the first time I read about it was the early 1980s, and I'm sure there were a lot of people who'd already been talking about it. And it was very hypothetical. Oh, by the time I'm in my 40s, this city will be as warm as that city. And but as that science emerged, I started reading more and more about it. It became more plausible and more real. So before I even became a college student or let alone a graduate student, there was already a pretty good sense of this is happening. It's coming faster than we had expected. Maybe the effects aren't what we originally expected, but they're not great. They're going to require some adjustment. What's interesting is, I studied climatology, and climatology was a field before there was climate change as a global problem. It goes back centuries, and depending on how you look at it. But some of the original maps of the climate system, are over 100 years old, before we really had a good working model for what could happen to the climate because of industrialization. So I was working in a field that had this old tradition, but also was kind of the original climate science, but now is expanding to include other fields because it's more than just looking at what happens to temperature and precipitation patterns. You also have to look at things that might not be in the domain of climate or atmospheric science, like issues with the ocean, the way that the ocean exchanges heat with the land and with the air above it, the way that vegetation responds to certain climatic factors. So by the time I was in graduate school, it was very clear that climate change was becoming kind of a fundamental part of climatology, even as the discipline of climatology would always continue in some manner. Kind of much the way, think of how not everybody who is in medicine studies, infectious disease, but then you get one event like a pandemic, right? A global scale disease outbreak, and all of a sudden everybody needs to learn how this affects their practice. And that's kind of what's happened in climatology too. It's become an important background that you can't, it's increasingly difficult to do climatology without talking about climate change. So I would say it was very organic in that it just got folded in to how I was learning about the physical world.
Would you say that it became a story for you to see the world with? And the story started out rather simple, see Dick and Jane run, and it became more a novel, a film as you went on?
I mean, the story analogy is really good because that's what I do for my job with the Department of Natural Resources is I have to turn the science of climate change into a narrative so that people can understand it. I have to turn the complexities of what we are reading about in the scientific literature into something that you can talk about day to day. So that's a really good analogy. In terms of the arc of the story, it's even different from what you described because we're kind of in I don't know if I want to call it a page turner, a nail biter, a cliffhanger, but we are learning new things all the time. It's and there's always some suspense or mystery about, well, what are we going to learn next? I mean, just since I started working for the DNR in 2015, because before that I was in kind of academia, working at various universities. When I started working for the Department of Natural Resources in 2015, what was then established climate change science was had made several advancements over what we had learned when I was in graduate school. And then since that time, we've also learned more. So it's an evolving story. Not only is the climate changing, but our understanding of how it's changing and what it means is also changing.
So as you are learning, was there a point where you said, I have to do something individually? And what kind of things do you do day to day?
Yeah, sure. So there were sort of two pieces of that I can address. The first is, I think whenever there's an issue, right? If we're all on a boat and the boat starts sinking or we have to save something, it's a good thing to take stock of who has what skills to help us out of this situation. I was a natural communicator. Ever since I was a kid, I just loved talking to people. I'm not saying I'm any good at it. I'm just saying I did it a lot. I was telling people about the weather that they didn't want to hear about. This storm's coming. I was boring my family and my friends, but over time found sort of an audience that did want to hear me talk about weather, extreme and hazardous weather, and wasn't going to, put me in a headlock or make fun of me for it, and things like that. So I realized the way I can help is through communication.
Okay.
Right? I mean, there are better scientists than me for sure. There are people who run computer models, and there are people who understand atmospheric chemistry better than I do. One thing I knew I could count on was that if I understand this, I can tell people about it. So that was kind of one piece. What's my job? As a climate scientist, I realized pretty early my big contribution is probably going to be in the communication realm because it's something I enjoy and really can't stop myself from doing. So that was one thing. Now, in terms of personal habits, this is just like the climate change science story. It's ongoing. My spouse and I, our whole family actually makes, tries to make intentional decisions about everything, from diet to, do we really need to drive? A big one is, do we need to buy this thing new? That's, I think, one thing that's kind of low-hanging fruit that a lot of people don't realize. If you are looking for something, if you need something in your life and you're thinking of buying new, it's always worth looking around to see if maybe there's a used version that's just as good, going to save you some money too, and is going to prevent something from going through a manufacturing process as a result of your purchase. So,
and we can avoid packaging.
Oh, yeah, that's a great point too. Yeah, a lot of these new products come in plastic packaging, and have added weight that produces more shipping costs, and also the whole shipping process puts more of those greenhouse gases into the atmosphere. So it's, I would say ongoing. I have teenage sons. They're not necessarily on the exact same lifestyle page as we are, but they also understand this is their future that they're inheriting, and they didn't have a lot of say in the future that older generations have created for them.
Well, at this point, what I'd like to do is I'd like to begin to examine three graphics. The first one has to do with greenhouse gases. And one of the reasons why I chose this graphic was, to me, I now see GHG everywhere. And that's fine if you're a working professional. You need shorthand so you can move on to the good stuff.
Right.
But my sense is that an awful lot of this stuff just sort of turns into a miasma. And what exactly is a greenhouse gas, and why does it affect me, and why do I have to worry about it? So that's the reason why I chose this. So I get, if you could just go down the line as far as what is the most worrisome greenhouse gas?
Sure. Well, there's kind of a neck and neck competition here. So should we back up and say what a greenhouse gas is?
That would be even a better start.
Yeah. So greenhouse gases, they're called greenhouse gases because they have an absorptive property.
Okay.
They absorb a certain type of heat energy that passes through it. It's called long wave radiation. It's, in other words, science can be very off-putting to people just from the terminology alone, let alone the actual science. So when we talk about long wave radiation, what we're really talking about is everyday heat that every object emits. Anything with a temperature above absolute zero, which is literally everything, emits some amount of heat off of it. You notice this the most when you're in a small room, right? And you can actually feel your own body heat sort of heating up that room because you are emitting heat until you in the room become the same temperature.
Right.
You will just keep emitting heat into that room.
Yep.
So there are gases that act to absorb some of that heat. Now this has to do, with the molecular composition of these gases, which we probably don't need to get into, but that type of heat has a relatively long, it's invisible, but it has a relatively long wavelength. It's much longer than the wavelengths that come from sunlight. Direct sunlight is what we call shortwave radiation. These gases allow that shortwave radiation or sunlight to pass right through. And then when it hits the Earth, it gets absorbed by the Earth. It depends on what part of the Earth it's hitting. If it hits a snowpack, some of that light bounces off because snow is very reflective, but if it hits a dark, kind of massive surface, it will be absorbed. And then once that heat is absorbed, it will start to emit. The heat will then get re-emitted back into the air above it, and that starts warming the air, and of course heat rises. And as the heat is essentially attempting to escape to space, which is where it would just end up getting evacuated into space, these greenhouse gases will trap some of it. And of course, the primary greenhouse gases that were already in the atmosphere before we came and just started kind of changing things were carbon dioxide, the nitrous oxides to an extent, but methane in particular, water or water vapor. This is the gas form of water, so whenever you see steam, and even invisibly when you can't see steam, there's some amount of water in there. These are the gases that really do a good job of holding on to they hold on to some of that heat that would be escaping. Of course, the reason that we're concerned about the greenhouse gases now is because, and I always point out, nobody did this on purpose. Through the wonders of technology, the Industrial Revolution and all of that, we started burning a lot of things, right? We were burning it for heating purposes, we were burning it for manufacturing purposes, for production, for pretty much everything. And the byproducts of a lot of that burning, because we were burning oil and we were burning coal and we were burning wood, which eventually breaks down into carbon and releases carbon dioxide, So all of these processes released additional greenhouse gases. And so we started increasing the amount of those gases that live up in the atmosphere. It's really throughout the atmosphere where they then absorb some of that heat that's escaping off of the Earth. And so we didn't turn up the dial on the sun at all, right? The
Nope,
sun's
that
been
stayed the
doing
same.
pretty much the same thing. And so what these gases do is they don't really intensify the incoming sunlight. So it doesn't get hotter right away just because we have greenhouse gases, but instead they hold on to more of that stored up heat when it would be escaping. And that's how we get warmer. The analogy would be you're in a cold room, you put on a thin blanket to cover yourself, and it traps some of your heat, but maybe not enough. So you put on another blanket. And at some point you get to the point where you're now trapping too much of your own heat and you have to throw a leg out, right? To get comfortable. But this is essentially when you add an excess of greenhouse gases, it's kind of, it's kind of like having too many blankets on.
Right. I think you covered both the first graphic and the second graphic pretty well. So what I'd like to do is now head to the very last one.
Sure.
I want to talk a little bit about consequences.
Sure.
And this graphic intrigues me because Minnesota, principal stream of revenue is agriculture.
Right.
So what do you see as best case in terms of what agriculture will look like? Pick a time, I don't know, 20 years from now, 30 years, and the worst case?
Yeah, those are really good questions, and there's multiple cases.
Sure.
Right? In fact, it is likely that we will experience both best cases and worst cases within, a couple decades because of the normal variations in our climate, the normal ups and downs. In Minnesota, what climate change has meant so far is warmer winters, longer growing seasons. It's, again, not every year, but on average, a typical winter now is warmer than it has been. Warmer summers, but not necessarily with more extremes of heat. It's generally been, because of that greenhouse effect, it's mostly that we've been seeing our warming when it's normally coldest at night and in the winter, summer nights, and but eventually we will see warmer summer days. So when the climate projections tell us that Minnesota is going to continue warming, it's eventually going to see more extremes of heat. We've been, in general, seeing more precipitation. Of course, we're talking about this in the middle of a drought, and that's what's been on people's minds. But drought right now doesn't have a really strong link to the changing climate because so much of what we've had over the last several decades has been more precipitation. If it would take a lot of drought to kind of undo that trend. So the signal for agriculture has been, they've had some great years. And, we can't really talk about agriculture in a vacuum because there's this other side where the plant genetics, the chemistry involved in producing, certain fertilizers and whatnot, all of that has improved for the kind of traditional big farm type systems, the production agriculture. So that's kind of helped to make some of these crops more resilient. Come back to a word you used, against climate and climate change. What we have seen, though, is kind of a mix of really good years and really tough years. So 2021 would be a tough year for farmers because of the drought. 2019 was a pretty tough year for a lot of even major, large farmers, large plot farmers, because it was so wet. We had standing water in the fields. In fact, much of the 2010s were a mix of terrible and wonderful. We had record production in 2015 and 16.
Would you say that that's what we're headed toward? That instead of having, we will oscillate between terrible and wonderful with little average in between?
That seems pretty solid. Honestly, the one thing that when we talk about climate change, we have to remind people, not every year is going to be the worst year, and not everything is getting worse. There are some things in Minnesota, and also Minnesota's looking pretty sharp compared to some other parts of the country in terms of the impacts, the symptoms that we have. All that said, communities have struggled in Minnesota to keep up with climate change such that you do have a resilience officer in St. Paul now, because it is hard to keep up with the changes. But when you then look at how we're doing versus some of the Gulf Coast states or versus parts of the West, wow, we've actually got a pretty good situation here. So, and when you're just looking at agriculture, I think it's, there are going to be some years where we have kind of cool summers that are moist, but we get ample sunlight, and there's going to be enough dry periods that I think, like 2015, where farmers will do quite well. There will also be other years where it's astronomically hot and everything dies pretty quickly. And I think that's, if we look at the climate projections, that's guaranteed to happen. So it will be a mix. And agriculture is all about risk reduction. And so for farmers to understand that they're going to have this, it's sort of like you take the normal range from Minnesota and you just expand it a bit. I mean, Minnesota's always been an extreme environment. And most people who work outside know this already. It's just that certain types of extremes are going to be moving farther and farther apart from each other. So the range between them may at times seem like it's grown. And so that could make for some tough times. Now, the other consideration is the smaller farmers who don't necessarily benefit from the relationship with big ag and aren't using the advanced crop genetics. And there are some of them in St. Paul who have very small plots or who work neighborhood plots. And these farmers generally have struggled more with things like draining their fields. So the wet years hit them harder, the dry years also hit them harder because they don't necessarily have an irrigation system. And so for those small farmers, I think getting as much support from University of Minnesota Extension and from other resources so that you are equipped to handle the changes that are coming, in addition to the ones that are already here, I think would be really important.
Thank you.
Sure.
My guest today has been Dr. Kenneth Blumenfeld, Senior Climatologist at the Minnesota Department of Natural Resources. If you have any comments or ideas for future programs, you can post them on the Affirming Flame Facebook page. That's the Affirming Flame. I hope you'll join me for the second episode in the Ark, St. Paul, Head in the Sand, or Eye on the Ball. I'm Kel Heyl.